So for a fixed C, rho is constant. Okay. So under this condition, when that is for a fixed C, rho is constant, we can say that the magnitude of the C vector, why we have taken magnitude, because as we are going in different direction, the vector quantity of C will change, but the magnitude is remain same. That's why C is constant. So C square is constant, or if you remember, C square was equal to E square plus V square plus W square, which is also constant. Now what is the meaning of this equation? It means that U, V and W can vary, but sum of their square, that is sum of U square, V square, W square, which is equals to C square, will remain constant. So for example, suppose if you take only two quantities, U square plus V square equals to C square, suppose it is constant, and C square is 16, which is 4 square. Okay, so now we can make 16 in various ways. Okay, so U square plus V square equals to W square, which is C square, which is equals to 4 square, which is 16. Now we can make 16 in different ways. So first one is, suppose 9 plus 7 equals to 16. So U square in form of U square by V square, how can we write 9 plus 7? It is 3 square plus root over 7 whole square. So now U is 3 and V is root 7. Now again we can write suppose 12 plus 4 equals to 16. So in form of U square plus V square, what will be 12 plus 4? It will be 2 root 3 whole square plus 2 square equals to 4 square. So now U is 2 root 3, V is 2, but C square is again 16. Okay, like this. Okay, another example, suppose 8 plus 8 is equals to 16. So here it will be 2 root 2 whole square plus 2 root 2 whole square equals to 4 square. So now U is 2 root 2, V is 2 root 2, but C square is constant. So in this way, here U and V is varying, but C square is remaining constant. So here also U, V, W can vary, but C square will remain constant. Now to express it in a diagram, suppose again we have a velocity diagram. Okay, along x-axis we are plotting U, and along y-axis we are plotting V. So U square plus V square equals to C square is where C square is a constant, is an equation of a circle where the radius is equals to C. So suppose this is C, and here this is also another radius which is equals to C. So here, so if you take projection on x-axis, you will get U, and projection on y-axis will give you V. So it is one set of U and V. Then if you for another radius, if you again take projection on x-axis, you will get another set of U2 and V2. So you see, this set of UV and this set of UV, they have completely different values, but sum of their squares will give us the radius, which is C square, which will remain constant. So similarly, in this case, it is an equation of a sphere, right? Where U, V, W, U square plus V square plus W square equals to C square. C square will be the radius of the sphere, which is constant. Now, as rho is constant, so we can say that N into Fu, Fb, Fw is also constant, which we can write as a function of another, some function f of another constant quantity C. Because N, Fu, Fb, Fw is constant, we can write in a different way, new way, which is N into some function f of another fixed quantity C. Okay. Now we can further modify this expression and we can write it like this: n another function phi of c square. Okay, so how can we write this? Suppose we have one function g of x equals to 3x to the power 4 2x cube plus suppose x. Now we can write this equation like this. Suppose 3x square whole square plus 2, we are writing x cube as x square whole to the power 3 by 2, then it will be x cube, only 2 will get cancelled out and it will be x cube, and we are writing x as root over of x square. So we can express this equation as a function of x square. Okay, so it depends only how you write the equation. So here you see gx equals to hx square. Okay, similarly if we have some function of c, it can express as a some another function of c square. Okay, so we have written that rho is in some function phi of c square, which is constant because rho is also constant. Now remember, rho is the number density of molecules in velocity space. Okay, so you see that now the number density depends only on c, the velocity. Okay, so this equation gives us an idea that how the number density depends on the velocity. That is, if the velocity changes, the number density will also change. Okay, in other words we can say that if we put different values velocity in this equation, we will get different values of number density. It means that different number of molecules are moving with different velocities. So we can say that there is a distribution of velocities among the gas molecule. Not all molecules are moving with the same velocity, because if you put different values of c, you will get different values of rho. Rho is the number density. So different number of molecules per unit volume are moving with different velocity. Or in the other way around, we can say that at different values of velocity, you will find that different number of molecules per unit volume will be moving with that particular velocity. So we can say that this from this equation we get an idea that there must be some distribution of velocities among gas molecules, and we started with the aim that we have to find the law of this distribution, that is how the velocities are distributed among the gas molecules. Okay, so if we can now n is the total number of gas molecules that is that you can know. Okay, so we have to find what is the value of phi c square, what is the value of this function, what is the nature of this function. If we can find what is the nature of the function, then we'll be done with the derivation of the law. Okay, so we can then we'll get the distribution law. Okay, but we don't know phi, what is the value of phi. We just assume that there is some function phi c square which is related to rho in by this expression. Okay, so our next step is to find what is the value of phi c square, which is phi c square is fu fv fw. If we can, that is, then we have to find fu fp fw. So our next step is to find what is the value of phi c square, which is we have to find fu fp fw separately. If we can find what is the value of this expression or phi c square, we will get how the velocities are distributed among the gas molecules.